Today we're going to take a look at section P1, which is real numbers and their properties. And the first thing I'd like to start out with is actually a diagram of the real number system. So when you first start learning to count, like my 7-year-old, what number do you learn to count by starting with? 1, right? And you don't go 1, 1.1, 1.2. You don't do anything like that, right? You go 1, 2, 3, and so on. So the little box on the inside, the very innermost box, are what are called either the natural or counting, sometimes called counting numbers. And these are the numbers 1, 2, 3, and so on. Very quickly in kindergarten, though, as you're learning to count, you encounter the idea of having nothing, right? It happens usually in subtraction. Even if in addition, they'll use the number 0, and they talk about 0 representing having nothing of something. So adding just the number 0 in actually broadens your view of numbers just a little bit, and that's the next box, and those are actually now called the whole numbers. So they include all the numbers that are already inside the little box in the middle, but they also include the number 0. So in a very real way, you can actually write them down much like we did before. You just start with 0. 0, 1, 2, 3, and so forth. Along about 5th or 6th grade, somewhere in there, depending on your curriculum. My 6th graders haven't quite gotten there yet in their curriculum. Somebody starts talking about negative numbers, right? And that includes all the numbers you had before, because we call them integers. Sometimes we will refer to them as the positive and negative whole numbers. So you kind of go from the left-hand side, you've got -3, -2, -1, and then you start in with the whole numbers and the positive numbers 0, 1, 2, 3, and so on. So everything is still a whole type number, right? No fractions, no decimals, none of that yet. The last outer box that's sort of like nested here does include those fractions and decimals. So we call these the rational numbers. Rational comes from the root word ratio. So ratio means fraction. I mean, that's really what it's referring to as your fractions. At least your fractions that can be written as an integer over an integer. So I can't list them any longer in this sort of, 3 numbers and then a dot, dot. I can't do that anymore with rational numbers like I was before. But they are numbers like, 1/2 or 0.67. So you've got your decimals, you've got your rational numbers, or your decimals, and you've got your fractions that are included here. But there are some types of numbers that we've still left out. In particular, they're the numbers that are on the other side of this box. And the numbers that are on the other side of this box are the irrational numbers. And much like when we got to the rational numbers, there's no way to sort of write them out in an enclosed form. I just have to give you some examples. And you have seen some of these examples for a really long time. For example, the number pi is irrational. So why is it irrational? Well, it's irrational because it can't be written in a fraction form with a whole number or an integer on top and bottom. Sometimes we approximate it as 22/7, but that's still an approximation. Or we'll approximate it as 3.14, but that's still an approximation. It has more decimals that extend beyond that, and they never repeat. That's an irrational number. Another irrational number that you may or may not have seen, depending on your mathematics background, is the number e. Sometimes you see that in some upper-level math courses. An Algebra 2 course might have it in it. Definitely if you took pre-calculus, you've seen e. And some others that you've seen and you might not even think about being in this category are radicals that don't have a closed way of simplifying them, right? Like square root of 2. So square root of 4 doesn't go in here because square root of 4 simplifies to 2. And that's on the other side of the box, right? But square root of 2 doesn't have that ability. If you put it into your calculator, it'll do much like pi does. It'll give you a decimal expansion that never repeats or stops. So we actually have our radicals over here as well. So this is kind of our world view of numbers. We do get things a little bit bigger, and we will toward the end of chapter P even, and we'll start talking about what happens when we have negatives underneath radicals. But this is the real number system. So all of this combined with all the boxes and everything are our real numbers broken down. There's some properties that real numbers have. Some of them are so familiar to you by now that you don't even think about them at all when you use them. And others of them are less familiar, or you might remember the name of the property. The first one is actually that's listed here is the distributive property, right? We can sort of distribute across there. So this is the distributive property. Let me move this over, actually, so that you can put it wherever you want. But this is the idea of taking that number at the beginning and multiplying it through the parentheses. So -3 times x and -3 times -4. That's the distributive property. The second one doesn't look like you can really simplify it, and you can't, but there is a property at play here that we use quite frequently, and this is one of those ones that you don't even think about it when you use it. Y times x is the same as x times y. You've used that since you learned your addition facts, like probably since kindergarten, first grade. Because when you started learning, your addition with your eighths, you didn't really have to learn that much more because you already knew what 3 plus 8 is. You didn't really have to relearn what 8 plus 3 is. You just knew they were the same, right? You changed the order. So addition has that ability to change the order, and so does multiplication, right? So our flashcards, our multiplication facts are the same way. 2 times 5 is the same as 5 times 2. And this property is one that we don't often think about because we use it so frequently, and it's called the commutative property. And in fact, that same commutative property is what allows us on this example number 3 to be able to redo values. It allows us to adjust things. But also on number 3, what we see in play is we see the ability to regroup. So if we change the grouping and we group the 5 and the 4 together, because they're like, right? I mean, I could do something to simplify them, and I move the y out. That actually is the property called the associative property. The associative property allows you to reassociate what's going to be grouped together. What I was mentioning about with the commutative property is, again, you could change that 5 times 4 then into 4 times 5. I mean, like that would be the commutative property at play within the same problem. But the regrouping of values, associating them differently, is the associative property. The last two are absolute value properties. So they don't necessarily have a name, just that they're properties associated with absolute values. But the idea really with absolute values is that they're measuring distance to 0. Okay? So if you're measuring the distance from -3/4 back to 0, that's still just 3/4. And if you're measuring the distance from 3/4 back to 0, that is also 3/4. So these are absolute value properties. And what I'd like for you to remember is that it's really just measuring the distance to 0. That's why everything becomes positive. It's because distances are positive. All right, so continuing that idea about distance, not only can we measure the distance back to 0, we can also measure the distance between other values. So the distance between points A and B on a number line is actually A minus B. Just subtract them. And we put them in absolute values because we don't really care which one's first or second because distance is positive. So you could write this as absolute value A minus B. You could write this as absolute value B minus A. It just doesn't matter. What we tend to do oftentimes is not even think about the absolute value. We just take the bigger one and we subtract the smaller one, right? And that automatically gives us a positive number. Now, on these two, we actually see values that are negative. And so I'd like to show you a couple of different ideas, both the definition that I just gave you, but then also a number line perspective of how to think about distances between numbers. So one option is that we could simply take the negative 3 minus the 14. I'm sorry, minus the negative 14. Right? We're subtracting negative 3 minus negative 14. Or if you'd rather, you can do negative 14 minus negative 3. It doesn't make any difference. And you remember that when you have two negatives next to each other, what do? Yeah. What it really means is that you have the opposite of a negative, and the opposite of a negative is a positive. So these two signs, I don't know if that's a great color. How about I use the black? We'll switch to positive. So on the first one, if I've thought about it this way, I now have negative 3 plus 14. If I've thought about it as I've done on the second option, I would have negative 14 plus 3. Okay, so what is negative 3 plus 14?
11.
It's 11. So unfortunately, 11 inside of absolute values just looks like a whole bunch of sticks. But I've got the absolute value of 11. If I do it on this one, I've got the absolute value of negative 11. But either way, when I take the absolute value, I get 11. Now, on a number line, what you see is here's my number 0. And if I have negative 3, I'm right here because I'm 3 to the left. 5, 6, 7, 8, 9. All right, I'm going to have to extend my number line. That's far enough. Let's see, 4, 5, 6, 7, 8, 9, 10, 11. All right, here's negative 14. So what we're actually measuring is we're measuring the amount of space between here and here. Remember, it's space. We're not counting hash marks. We're measuring spaces. So when you're counting, make sure you're counting the right things. You're counting the blank spots, not the hash marks. And if I count this, I will also get 11. So that's another visual way to think about distances, especially when the numbers are small or if you're learning them for the first time, something like that. Any questions so far? Okay, so chapter P can be a little bit overwhelming. I know you're like, I'm not overwhelmed yet. Most of you are like, I've seen this and I'm good. Maybe you're even bored, and I'm sorry if that's the case. But the reason that chapter P can be a little bit overwhelming is because we change topics really quickly. And we look at another piece, and we look at another piece, and we look at another piece. So the breadth that we cover of what's going on in chapter P is very wide. So we're going to change gears, and we're going to move into exponents very quickly in P.1. All right, so exponents are the idea of repeatedly multiplying something. So over here, we have the expression a to the power of n. And what that means is we have a multiplied by itself n times. Okay, so for the purposes of what you're doing in terms of your homework, showing work and things like that, I know your calculator can do this stuff just fine. I'm not interested in what your calculator knows how to do. The numbers are quite small. You can handle the numbers yourself, so I'd like to see you express to me what this means. So on the first one, for example, it says negative 3 to the power 4, and I would expect to see you actually write out negative 3 4 times. Now, nobody's going to have you write this out 50 times. That's just not going to be a thing, okay? They're going to be small enough numbers that you can express what's actually going on there. Now, interestingly enough, on this one, we have a bunch of negatives. In fact, we have 4 negatives. And anytime I multiply 2 negatives together, what happens? Yeah, they cancel. It becomes a positive, right? So every 2 of these becomes positive. So these 2 actually change the signs to positive. And then these 2 over here, same thing. I change the signs to positive. So when I'm all said and done on this particular one, I end up with a positive number because everything ended up being positive. So I am going to have a positive number. You don't necessarily need to write positive. I'm just going to write it down because we've already talked about it. And then you have 3 times 3 times 3 times 3. 3 times 3 is 9. So if you're thinking about pairing them up, this would be 9 and 9 then, and 9 times 9 would be 81. You bet. So you can either write positive 81 or just 81 is fine, of course. I specifically chose these 2 examples because I want you to see that those parentheses matter. They change things. So when I see those parentheses on the first one on this slide, it tells me that I'm taking everything in the parentheses and I'm multiplying that out 4 times. On the second one, that's not what it says because there's no parentheses, right? What it says is that I have a negative, and then what is actually being raised to the power 4 is just the 3. So on this one, I have 3 times 3 times 3 times 3. Same 3's as I had before, but I only have 1 negative, not 4 negatives. And even as I say this, probably most of you are saying, yeah, I already know that. And half of you are going to do something where you're going to mess it up for me. Because it's an easy thing to just overlook and say, well, there's an even power, so it's going to all become positive. So be really careful with those parentheses because it's an easy mistake to make. So this one ends up being a negative because there's only 1 negative, and then of course I have the same 4 3's, so I have an 81. So I have negative 81. Any questions? We're good so far? Okay. I have no idea why on this one, when it printed out, it like shifted it to the middle of your box. I don't know what's going on. That's super weird, but order of operations is where we're going to, I think it's the last topic in this section. Yeah. And what I want you to remember is that there is an order and it does matter. There's nothing innate about our order. Like there's some things that we just kind of feel like, you know, like are God-given, like the structure and the order of things. I don't think order of operations really qualifies like that. The reality is that in order for me to do a problem and for Hope to do a problem and us to get the same answer, we have to have a structure that's common between us, right? Otherwise, things don't make any sense. So there has to be some kind of structure that's decided upon and that everybody uses all the time. There has to be. Oddly enough, I had a student who's actually, he's a med school student right now. He was a student of mine a number of years ago. And in the middle of last semester, he actually sent me a question. And it was an order of operations question because it showed up on some social media, whatever. And he was pretty sure he knew the right answer. But people were arguing about which one was the right answer about order operations. People do weird stuff on social media. Y'all know what I'm talking about, right? So this was an argument. So he wanted to know, was he right or was he remembering it wrong? So if you'll remember, order of operations has a pattern to it. I think I'll just write this over to the side. So you might remember the phrase PEMDAS, or that word PEMDAS. You might remember the phrase, please excuse my dear Aunt Sally, as a reminder of the letters in the word PEMDAS. And while PEMDAS is fine, the reality is that they don't really go together like this. The reality is that the M and the D are interchangeable, and so are the A and the S. So instead of remembering PEMDAS, we could remember PEDMOS, and we would be equally correct. So it's just be really careful when you're doing like a multiplication or a division that you don't think, well, multiplying has to come before dividing. No, it doesn't. Multiplying and dividing are actually the same operation. We think of them differently, but they're the same operation and they can be done in the other order. So P stands for parentheses. E stands for exponent. or exponents. The M and D, of course, are for multiplication and division. I'm just going to write multiply, divide. And I'm going to remind you over here, it's left to right. It's not multiply first, divide second. It's multiply and divide from left to right. And the same thing's true for addition and subtraction. So I'll just write add, subtract. And again, it's from left to right. And parentheses also is a little bit of a funny term. Parentheses really refer to any grouping symbol. So they might look like the parentheses, like what I've been writing here, you know, like this. They might also actually look like brackets. Or maybe they look like curly braces. They're just talking about grouping symbols, okay? Just how things are grouped together. So in a very real way, the absolute value here is acting also like a grouping symbol. I know it has the additional caveat of we need to talk about distances, but it also groups things together. So we want to be careful that we're aware of that. So on this one, when we're working on it, we do see some parentheses. And often when we're working on order of operations, it's also a good idea to think about I'm working from the inside out. Because the inside is usually where you think about when you think about parentheses. So if you have the ability, and we do here, to simplify within the set of parentheses, that's the first thing you do. So the first thing that we would do then is that we would multiply 2 times 3. And that would give me 6. Yeah. And I don't need the parentheses around it anymore. The parentheses were simply for the point of connecting the 2 and the 3 together. All right, so I don't have to actually worry about using them any longer. So again, working from the inside out or working inside a grouping symbol, I'm still working inside, in this case now, the absolute values, because that's my grouping symbol that's going on. So I've got 4 minus 6, which gives me -2. And now it matters that I have an absolute value more than just the fact that those are not parentheses here, because the absolute value of -2 has a value. It is 2. And the last thing I would be doing is 5 minus 2, which gives me 3. Now on that one, and on many of them, you won't have all of the things, right? Like there were no exponents on this problem. I didn't have any division going on here. That's okay. It's just an intermixing of different components. So let's try just a couple more. And then there's a slightly different example. Okay, so much the same as the last problem, except that it doesn't have absolute values. It only has the parentheses. So we have these parentheses, and we're going to work inside the parentheses. But within the inside of the parentheses, there are 2 operations. There's subtraction, and there's multiplication. Right? There's 2 operations inside of the parentheses, and we still have to do them in the proper order. And proper just means the same. And this is the order that's been established. The proper or the same order here means that which one do I do first, the multiplication or the subtraction? The multiplication, because the MD comes before AS in PEMDAS. So the first thing I'm going to do is actually do the multiplication. So I'm going to leave the -2 and the -3, all that's going to stay the same. And a 5 minus is going to stay the same. And now I just have 2 times 8. And 2 times 8 is 16. Audience participation. The sooner you guys answer, the sooner we move on. That's the goal, okay? Yeah? All right, cool. All right, still inside the parentheses, because we still have parentheses, but now we have only one operation to deal with. We have 5 minus 16. So what is 5 minus 16? -11, you betcha. Okay, all good so far. Now, I still have parentheses around the -11. I don't necessarily have to. If you don't want the parentheses there, you could just change it to the fact that this is now times -11. It doesn't matter. The parentheses are fine, but they're not parentheses like grouping symbols either way. So if you leave them, you still need to understand that you're not working on a parentheses step at this point. There is no more simplifying inside the parentheses. That's done. All that's left in this problem at this point is the subtraction, right? We've got the -2 minus 3 part, right? and the multiplication, which is the negative 3 times the negative 11 part. And it matters, because if you do negative 2 minus 3 first, and I do negative 3 times negative 11 first, we will get different answers. We will. So that's why it's important that we have a set pattern of how we're going to do it so that it always works out the same and we don't have miscommunication because of it. So we are going to do the multiplication first, right? We are. And so the negative 2 at the beginning is just going to stay, and now I really have negative 3 times negative 11. Yeah, and it's a positive, right? And you'll have a positive 33. So I don't actually have, or you could say maybe that I do have subtraction, but I kind of have addition now instead. Not that it really matters, but I have that last step. There's only one operation left. I have negative 2 and I have positive 33, which gives me 31. Yeah. Perfect. Number 11 actually moves outside of the realm of just looking with numbers. Some very simple algebra components that are going on, kind of things that you would see in probably 6th or 7th grade. And so what you have to remember is that pretty much all the stuff stays the same. All the properties stay the same. We still have PEMDAS going on, order of operations, all that's good. The difference in what you're seeing right here, though, is that inside those sets of parentheses, you can't simplify anything, right? I don't have a 2 times 3 that I can multiply together inside the parentheses. That's not going on. So as I'm taking a look at this, I don't have the ability to start with parentheses. There are no exponents. So moving down the list of order of operations, I'm looking at multiplication and division, and there is multiplication and division here. And it's, by the way, it's by the process of distribution. So the first thing we're going to do on this one is multiplication through distributing the values through the parentheses. So I have 5 times 4 is 20. I have 5 times negative 2x, which is negative 10x. And then make sure that the negative is still connected to the 2. So I have negative 2 times x for negative 2x. And then I have negative 2 times negative 5 for a positive 10. So that's my multiplication step. All right? The only thing that's left is addition and subtraction, and we can sort of shuffle things around if we want to. That's the associative property, so that we group together the like terms. You don't necessarily have to rewrite it, but the terms that are alike here, the first ones are 20 and 10, because they're both just constants. They don't have an x associated with them. They're both positive, so I can add them together, and I would get 30. The other two are also like terms. Like terms here, negative 10x and negative 2x, because they both have a single x attached to them. They're both negative. So I have negative 10 and I have negative 2, which gives me negative, because it's addition, not multiplication, 12, and x. So it's negative 12x. I can't combine the 30 and the negative 12x. They are not like terms. One has an x associated with it, which really means it's 12 times x. And that's really what it means. It's 12 times x. And the other one doesn't. So I'm stopped at this point. There's no more simplification that I can do. Okay, the last piece that we're going to take a look at, still order of operations, is going to encompass evaluation. So evaluation is the idea of taking some kind of a general expression. Maybe it's something very specific like this one, or maybe it's something where you always know you're doing A plus B. And you're just taking each of the letters and you're plugging the values and you're substituting them in for the value that they represent. So on this one, for example, the A is negative 2. So everywhere I have an A, I can put a negative 2. Notice I put that negative 2 in parentheses. I did that on purpose, because A is squared and A is negative 2, so all of negative 2 is squared. On the other part, the B value is negative 3. And the C value is 0. So you'll see parentheses used a lot when you're substituting things in if there are other operations at play. In this case, multiplication on top, some subtraction on top. But you notice I didn't put any parentheses on the negative 2 on bottom. I could, but they're just not necessary. There's nothing else there. It's just one number. As we're working through this, we should be looking at order of operations. Order of operations says we do parentheses. Well, there aren't any simplifications within parentheses, but there kind of is. What you actually kind of see is you see a numerator, and it's all grouped together. So for example, I can't take the -2 that's in the top with the squared and cancel it out with the 2 on the bottom, because that would be doing things across the parentheses, the grouping. The grouping on top means I have to simplify what's on top all together in one value, and then simplify anything that's on bottom, and then I can compare them and do any kind of simplification between. So starting on top, I have exponents. I didn't have exponents on the previous problems. And I do have an exponent's -2. What's -2 squared? 4. Right. This one's 4. On the last one, I actually end up with this being a big whopping 0 because I'm multiplying it by 0. So if you want to remind yourself and write that down for now so that you know that you did it, it's 4 minus 0 divided by -2. Or you can jump to the fact that it's just simply 4 divided by -2. And now there isn't anything else to simplify within the numerator or within the denominator, so we can compare them. We can actually do the division that's here. And what is 4 divided by -2? -2. And we would be finished. All right, perfectly timed, right at the end of class. So section P.1 homework is now assigned. You should be able to do that list of problems, the one that says P1, all the problems that are listed across. If you need help, come see me. I've got office hours. You can just send me you can book me appointment. We can talk. The Success Center, I don't think is probably open just yet. Feel free to work together. I don't have any problem with you working in pairs. I do have a problem with you copying somebody's work. That's not your good plan. But definitely you can work together. All right? Have a great couple days, and I'll see you guys on Thursday.